Good evening. Welcome to A-Level Physics, Cambridge A-Level. Let's try some questions from 2023, October, November, paper 1-2 and paper 2-2. Okay. We discuss about 10 questions. This is the multiple choice answer. A student estimate the maximum speed of some different moving objects. Which maximum speed is not a reasonable estimate? This is the hardest. Depends on general knowledge. So you check on what you know, see whether it's right or wrong. Well, I tend to go for Olympic sprinter, check that out. Fastest runner for 100 meter is about 10 seconds. That's what I remember years ago. So I just calculate 10 meter per second. So this is too high already. So I was fortunate. No? The others I hardly have any idea. Right? General knowledge is sometimes, that's why it means general knowledge you have to read widely. No? Nothing can be taught you by the teacher. This is straightforward. Which quantity is an SI base quantity? Force is a derived quantity. Newton is a derived quantity, is a derived unit. Given quantity. Second is a derived unit. So answer is time. D. Time is a base quantity. Right? These two look similar, but this is unit. They want quantity. Base quantity is time. A student takes measurement to determine the constant acceleration of a model car moving from west in a straight line. The measured value with the absolute uncertainty are shown. This is the measured value. The student uses the equation S equals to half AT squared to calculate the acceleration of the car. First, the acceleration of the car is absolute uncertainty. Subject your A, that's what you want. Acceleration, calculate A first. Acceleration from here. Put in your value. There's your 2. S is 16.5. T squared, 15 squared. Okay. Most of it is 2 or 3 significant figure. Okay. So it's 0.150. Then calculate uncertainty, fractional error in A. Right? 2 is a constant, so it doesn't have any fractional error. S is delta S over S plus 2. 2 is because of the square there. Delta T over T. And substitute. Delta A over A. Delta A is what we want. A is that's your A. Then delta S 0.1 divided by 16.5. 2 delta T over T 1 over 15. So multiply it out. Right? Usually uncertainty is one significant figure. So that is 2 decimal place. So this is 2 decimal place, just right. Right? You could have guessed from here. This is actually 2 significant figure only, not 0. Shouldn't put a 0 in. An aeroplane is moving at a constant speed in a straight line at an angle theta to the horizontal. 4 forces act on the aeroplane. The thrust, that's the thrust. The weight, W. The lift, force, L. right? That's the lift force L. And the resistive force R. That's the resistive force. Right? Cambridge is very kind. Give you a diagram. Which equation must be correct? Look it out. Right? There's your line parallel to your lift. Right? We solve along these two perpendicular line. So we solve it to this perpendicular, this so-called vertical line, this so-called right, at an angle to the vertical line. There's an angle theta. This angle is theta. This angle is also theta. Right? T equals to R plus a component of weight in this direction. W sine theta equals to T. Lift L equals to W cos theta. Then we just check, see whether there's an answer or not. Right? A is the answer. What is the definition of acceleration? Rate of change of displacement is velocity. Rate of change in kinetic energy is power. Rate of change in momentum, that is your force. So answer is donkey. Rate of change in velocity. An astronaut on the moon, where there is no air resistance, throws a ball. The ball's initial velocity has a component 8 meters per second and a horizontal component 4 meters per second, as shown. The acceleration of free fall of the moon is 1.62 meter per second, that's minus 2. What is the speed of the ball 9 seconds after being thrown? Okay, that hasn't changed. The horizontal component is always the same. Only the vertical one is the one changing. So we calculate the vertical one. Taking upwards as positive, that's the initial speed, u, and then acceleration is downwards. Right? We take upwards as positive, so it's negative 1.62, and then we are required the speed at 9 seconds. So 9 seconds, and choose a formula. We want to find the vertical velocity in the y direction. So u plus at, u is 8, right? That minus is that minus a 1.62, t is 9. So we get a negative answer. Negative answer show is downwards. Right? So there's horizontally is 4. That's a Vx. Vertically is downwards 6.558. So put it inside there. Vx is 4. That is 4. Vy is this one. So 7.70. Answer is B. Okay. 2 blocks of mass 0.2 kilogram and 0.5 kilogram are connected by a line in extendable string that passes over frictionless pulley. So we don't worry about the string and the pulley anymore. The blocks are initially held stationary. The block of mass 2.0 rests on a rough horizontal surface, so there's friction there. The block of 0.5 kilogram, this one, is suspended in air. Air resistance is negligible. When the blocks are released, they have an acceleration of 2.0 meter per second minus 2. What's the magnitude and frictional force between the block of mass 0.2 kilogram and the rough surface? I want to find the frictional force here. So draw the diagram so that you can see what's happening. There's your tension. Right? We separate them out. There's your tension. There's your frictional force, F. There's your acceleration. Okay? That is acceleration. Okay? Consider this one separately from this one. The force acting on this one. So let's consider this one. Okay? Consider the motion of 0.2 kilogram. Right? Don't bother about this one yet. So to go to the right, T must be greater than friction. Right? T minus F equals MA. N is 0.2. Put in your value. T minus F is 0.2 times 2 is 0.4, equation 1. Then consider the motion of this one, 0.5 kilogram. Right? There's your tension. Right? It's the same. The tension is forces acting on 0.5 kilogram. The tension is pulling it up. The weight is pulling it down. Right? Weight is 5 Newton. We approximate lah, because the answer is quite far away from each other. So no need to use 9.81 lah for objective calculation. We do faster, use 10. No? So 10 times that is 5 Newton. Right? Acceleration is still the same. It's still going down. Right? It's still going down. So for it to go downwards, 5 must be greater than t. So 5 minus t is 0.5. A is 2. 2. So 0.5 times 2 is 1. So equation 2. So we add them up, 1 and 2. T and minus t cancel off. So we got 5 minus F. Add these two. 1 plus 0.4 is 1.4. The answer is 3.6 Newton. Right? Remember, we use 10, so it's approximately that. We have to do fast, so we cannot spend too much time using calculator to be so accurate. Right? Approximately good enough. The resultant force causes an object to accelerate. What is equal to the resultant force? Acceleration object per unit mass? No. Change in kinetic energy object per unit time? No. That is more power. Change in momentum object per unit time? Right? There's your force. Change in velocity object per unit time? Right? Resultant force is change in momentum object per unit time. Right? Change in velocity object per unit time is acceleration. The answer is C. An object falls from a stationary helicopter and reaches terminal velocity. What happens to the acceleration of the object between leaving the helicopter and reaching terminal velocity? Right? When you have terminal velocity, it means that you have to consider air resistance. So where there's air resistance, right, besides the weight acting downwards, air resistance is opposing to the weight. So air resistance increases with velocity. So the acceleration will decrease. Right? That's what we show you. There's a weight pulling it down. There's a frictional force pulling it up. There's a motion downwards. That's the equation. mg minus force divided by m is an acceleration. So F start to increase, A start to decrease. Right? So A will decrease to 0, 0 at terminal velocity. Answer B. As the speed of the object increases, F increases. and the acceleration decreases to 0 at terminal velocity. Okay, number 10. Two balls of mass m and 2m traveling in vacuum with initial velocity 2v and v respectively collide with each other head-on as shown. After collision, the ball of mass m rebounds to the left with velocity v. What is the loss of kinetic energy in the collision? Well, draw whatever is given to us. V is given to us v and 2v. After collision, mass m rebounds to the left with velocity v. Right? Draw it. Right? It is a vector. Velocity is a vector. Momentum is a vector. So we choose the right as positive. So to the left is negative. Okay? We say rebounds to the left. This one we are not sure. So we can take it as to the right. If we get negative, then it's to the left. So we call it W. So conservation of momentum. Right? We want to find this velocity. So conservation of momentum first. Right? The sum of momentum initially. The sum of momentum finally. Initially is m times 2v. That one there. This one is negative. Opposite direction. 2m times v. And then after the collision, minus v times m. So minus mv. 2m times w. So we can calculate our w. This one will cancel off. M and N will cancel off. So W equals to half V. What is the loss of kinetic energy in the collision? Well, let's calculate the initial kinetic energy before collision. Half m times 2v squared. It's a scalar, so it doesn't worry about direction. Half 2m times v squared. So calculate out. We can. This is the initial kinetic energy. This is the final kinetic energy. Final one is minus half m minus v squared. Right? This is the final kinetic energy with minus. Right? We don't worry about this negative sign there because it's a scalar. And final one, this is the final velocity. So we minus the final velocity, half 2m. Right? Half is 0 0.5, 0 0.5 v squared. Simplify 9/4 mv squared. The answer is C. Okay, so that's the end of our session. Thank you.